Hello and welcome back to this course. In the previous session, we have developed a C code in order to calculate the simple interest. And within the code, we have used multiple instructions. So in this session, we are going to discuss the types of instructions in C. So let's start. Instructions in C are broadly classified into three categories. The very first is type declaration instruction. Now these instructions are used to declare the type of variables used in a C program. Any variable used in the program must be declared before using it in any statement. Declaration statement is written at the beginning of the main function. If you see the example, int base, that means an integer value, float rs, salary. So rs and salary variables are of floating type. That means the decimal numbers. Char, name, code. Now these name and codes are of character data type. C offer various data types that will be discussed in this session. Next is arithmetic instruction. Now a C arithmetic instruction consists of a variable name on the left hand side of equal to and variable names and constant on the right hand side of equal to. The variables and constant appearing on the right hand side of equal to are connected by arithmetic operators like plus, minus, multiplication, division. Let's understand with an example. Int, add, float, KOT, data, alpha. Now these are the variables and we have assigned a value. Add equal to 3200, KOT equal to 0.0056. So data equal to add divided by KOT plus 3.2 multiplied by 2 divided by 5. So this complete instruction is a type of arithmetic instruction. Last one is control instruction. Now as the name suggests, the control instructions enable us to specify the order in which the various instructions in a program will be executed by the computer. In other words, it determines the flow of control in a program. Basically, there are four types of control instruction in C. Number one, sequence control. Number two, selection or decision control. Number three, repetition or loop control. And number four, case control instruction. We'll be discussing these in details in future session. Now let's understand the computer number system. That means the number system that is used in digital computer. So basically, there are four types of numbers that are used in computers. Very first is decimal number. We all are familiar with this decimal number because we use in our daily life. It contains 10 different symbols, that is from digit 0 to 9. Now there are 10 different symbols, that's why it is called as base 10 number. Each position represent a fixed power of 10. Now this fixed power are calculated as positive on the left of decimal point and negative on the right of decimal point. If you see the example, 14.75 is the decimal number and this has been represented using the positional value. So if you calculate this, we'll get 1 into 10, 4 into 1, 7 into 0.1, 5 into 0.01, and adding all this we'll get the number that is 14.75. Next is binary numbers. Now this is the machine code that we have discussed in the overview session because machine understand only the language of 0 and 1. So binary number is the machine code that is understandable by the computer. Now it contains two different symbols, that is 0 and 1. Therefore it is called as base 2. Each position represents a fixed power of 2, and again on the left hand side of binary point the power is positive and right hand side it is negative. If you see in the example, 10.11, which is a binary number, is represented as positional value like 1 into 2 to the power 1 plus 0 into 2 to the power 0 plus 1 into 2 to the power minus 1 plus 1 into 2 to the power minus 2. Evaluating this whole result, you will get 2.75, which is the decimal equivalent of this binary number. That means if I'm entering 2.75 through my keyboard, then this 2.75 will be converted into binary, that means 10.11, and then sent to the computer processor. Next is octal. Octal has 8 different symbols from 0 to 7. That's why it is also called as base 8, and here the position represents a fixed power of 8. Again same thing, on the left hand side of octal point the power is positive and on the right hand side it's negative. As an example, 43.26 is an octal number, and if you represent this in the form of positional number, then 4 cross 8 to the power 1, 3 into 8 to the power 0, 2 into 8 to the power minus 1, 6 into 8 to the power minus 2. Evaluating this will give you 35.34375, which is again the decimal equivalent of this octal number. And the last one is hexadecimal. Now hexadecimal is the most commonly used number system in embedded C, or the programming of controllers. It contains 16 different symbols from digit 0 to 9, and after that the character A to F. That's why it is also called as base 16, and again the each position represent fixed power of 16. Now left hand side of the hexadecimal point is positive power, and on the right it's negative power. As an example, 7D.A4 is a hexadecimal value, and representing this in the positional power system, we will get 7 into 16 to the power 1 plus D into 16 to the power 0 plus A into 16 to the power minus 1 plus 4 into 16 to the power minus 2. Evaluating this, we will get 131.265625, which is again the decimal equivalent of this 7D.A4 hexadecimal value. Once this number system is clear to you, now let's discuss the various data types offered in C. Basically, there are 4 categories of data types. Very first is primitive. Primitive data types are char, int, long, float, double. Now if I talk about the range, then char is from minus 128 to plus 127. The value that has been represented in bracket is the value for unsigned char. That means if we ignore the positive and negative sign, then the range is from 0 to 255. Size is 1 byte, and the format specifier is %C. Similarly, int, that is integer data type, its range is from minus 32768 to plus 32767, and for unsigned int, it's 0 to 65535. Size of 2 byte represented by the format specifier %D. Next is long data type. Its range is minus 214748364 to plus 214748364 and for unsigned long 0 to 429496729. Size is 4 byte and represented by format specifier %LD. Next is float data type. Its range is minus 3.4 e raised to the power 38 to plus 3.4 e raised to the power 38, having size of 2 byte and represented by %F format specifier. The last one is double data type. Range minus 1.7 e raised to the power 308 to 1.7 e raised to the power 308. It is having the size of 8 byte and represented by %LF. After the primitive data type, we have derived data type. Within derived data types, we have array, which is a collection of similar data types in a list manner. Function, which is collection of statements and instruction. Pointer, the data types that hold the address of variables. Next is user defined data type, and we have enumerated, structure, union. Enumerated, that means the data types enumerated as different names as per user requirement. Structure, it is also a collection of data but of different data types. Union, similar like structure but difference in size in memory. And the last one is empty data type, that is void. Now void can be used within function and pointers. Now this data type doesn't hold any value. So if I talk about function returns as void, that means a function with no return value. If I talk about function argument as void, then a function with no parameter. And if it is pointers to void, then address of an object is considered instead of its data type. Now you must be thinking that how this range is calculated for primitive data types and what are this size 1 byte, 2 byte, 4 byte. So let's understand what does this mean. Let's discuss the signed and unsigned bit. So for that we need to understand the terminologies used in size. A single digit is called as bit. Group of 4 digit is called nibble. Similarly, group of 8 digit called as byte, and if it is 16 then it is called half word, and at last if it is 32 bits, that means 32 digits, then it is called a word. Okay, so whatever size has been given to the data types are measured as byte. Now if I talk about unsigned bit, so let's take a 1 byte data, that means 8 bits, and if we fill those 8 bits by 1, then the highest value that we will attain is 255. Now this value is calculated using the positional number of binary, that means 1 into 2 to the power 0, then 2 to the power 1, 2, 3, 4, 5, 6, 7, increasing from left to right. And similarly, if I replace by all zeros, then I got the result as 0. So if I talk about unsigned bit, then 1 byte is from 0 to 255. Similarly, if I talk about signed bit, then the MSB, that is the leftmost bit, is considered as signed bit, which is shaded as red in this section. So 0 represents the positive sign. Like if the MSB, that is most significant, is 0, then the rest value is calculated as is positive in nature. Similarly, if the MSB is 1, then 1 represents the negative sign. Okay, so if I take all ones considering the most significant as signed bit, then the value that I will get is minus 127. And if I replace all ones by 0 considering the signed bit for negative, we'll get minus 0. But if you see the signed bit, then there is two representation of 0. That means if I take this case, that means the positive 0. So this is the equivalent to 0. Similarly, this is also equivalent to 0 but in negative sign. So in the number system, 0 is neither treated as positive or negative. So we have to consider only one representation of 0, that means this. So what about this representation? So if you see this 0 representation in negative sign, then you will see it is the complement of this 127. Like if you see this value 1111111, then the equivalent is 127, and since it is 0, that's why it's positive. Okay, so now if you complement this, now you must be wondering what is complement. So let's discuss the ones and twos complement. Ones complement of a binary number is swapping of zeros by ones and vice versa. And similarly, twos complement of a binary number will be the ones complemented and adding 1 to it. Now this both ones and twos complement is used to represent negative binary numbers in digital systems. So if we take the complement of this positive 127, we will get this value. That means where 1 is present, we get a 0, and where 0 is present, we get 1. So this 127 gives you the minus 128, because if you calculate the decimal representation for this 8-bit value, then we'll get 128, but most significant bit is 1, so we get minus 128. Don't put so much stress on this. This is just a representation. We'll explore more when we will be going to use this thing in our code. So that's all for this session. In the next session, we will see the operators used in C.